it's been about 4 months since Rich and I were here last, and we're back to complete the trim out phase of the job, and it looks like the house is nearly complete.
Well, sure. The walls are painted, cabinets are up, all the doors are hung.
And it looks like there's about a half dozen guys here frantically trying to get this house done.
Yeah.
Hey, Grayson, how you doing?
And speaking of that, Eric, good morning. Glad to see our crew from Arizona Sound and Light is back. What are you guys where are you working on today?
I'm gonna try to get our security sensors knocked out today, and I'm gonna go check and make sure our cable's still intact.
Okay, good. I'll catch up with you soon.
And I'm going to start taking some equipment to the laundry room.
All right. Now, in the trim out phase of the job, we're going to be doing the following tasks: installing connectors on the cable and testing the cable, installing the outlet hardware and covers, installing the speakers and audio distribution equipment, installing the network support equipment and in the distribution panels, installing the security system and home automation equipment, configuring the equipment for this house and connecting outside services, and testing each system and network for proper operation.
And these are just some of the parts and equipment we'll use to complete the installation.
So you want to get started on the panel, putting some of this stuff in?
Sure, let's go take a look at the damage in the laundry room.
Oh, okay. Oof.
Well, Grayson, looks like the cardboard mostly did its job keeping the paint and debris out.
They really took a beating.
Yeah, it looks like there was a fight in the laundry room.
These guys lost. Got bad. I don't know what could cause this. Well, let's take the cardboard off and make sure we're okay underneath.
Okay. Well, Grayson, it looks like
Okay.
our cable's pretty well survived as well.
Yeah, and our pre-wire labels are intact. That's good. Okay, so what do we got?
Okay, we're going to go ahead and install the RF and broadband equipment in this panel.
Right.
The center panel is going to get our voice and data equipment, and the left-hand panel will get our security system, home automation, and audio distribution equipment.
Good. Now we're going to start by trimming the cables to the proper length and replacing the pre-wire labels with these permanent labels we made at the office.
We're going to go ahead and terminate the TP to the voice and data modules, and we'll connectorize the coax so that we can go ahead and test all the cable.
Right, we need to do that first. Okay, so let's get the cables sorted out into, I'll do voice and data here, you do internal and external there.
Okay. And then is there any more?
Yeah, I'm going to do it when I get this thing sorted. Rich, I tell you what, if you're going to start on the voice modules in here first, why don't I get the data and these camera cables kind of out of your way?
Well, that'll make it
Move
easier.
them over to your
sure.
side.
There's a place I
Temporarily.
can attach them right here.
Okay? Excellent.
Okay. Got it.
All right, now while you get started on the voice and data modules, I'm going to go give the ASL crew a hand putting the connectors on the other end.
Fine. Looks like I've got everything I need here.
If you don't call me.
Okay.
I'll be having lunch.
I won't. To make trimming the cables to the correct length easier, I'm going to go ahead and install the voice and data modules using the scaled drawing that we made earlier. This drawing tells me exactly where the modules should be located in the panel. The modules, very simply, snap into the holes right here in the back of the panel.
Rich mounts the remaining voice modules below the first.
These are going in upside down, aren't they?
Then 2 data line termination modules that share a common bracket. Then the third data line module about 6 inches lower.
Each voice network cable gets terminated to one of these 110 style punch-down connectors on the voice modules. The voice network diagram tells me exactly which cable goes to which connector. So I'm simply going to follow the network diagram and take cable 1A from the master bedroom and terminate it to connector number 1 and then work my way across.
To terminate the cable to the 110 connector, you'll need a TP cable jacket stripper and a punch-down tool with a 110 blade. A punch-down tool is used to firmly insert an individual wire into an insulation displacement contact. The contact cuts through the wire insulation, making a good connection with the copper. The tool has a removable blade with 2 ends. You can use either the wire cutting end or the non-cutting end. The wire cutting end lets you punch down and cut off the excess wire with one punch.
The first step is to strip off about 2 inches of insulation using the cable stripping tool. This tool ensures that you won't nick or damage the wires. Start with the orange or green pair, using the color codes on the connector. With the blue color contacts on the left, the white wire of each pair goes on the left. Keep the distance and pair untwisting to a minimum between the jacket and the contacts. Place each pair into the insulation displacement connector groove by hand and force them firmly in place, then punch down the pair with a punch-down tool. When finished, it should look similar to this.
Rich first applies the new trim-out labels, then carefully measures and cuts the cable to the correct length, then strips the insulation and punches it down in the right order. And finally finishes up with the last voice line. He then terminates the primary incoming voice line from the NID on the surge protection module. We'll wait till the cables are tested to interconnect each voice module. At each outlet location, we're going to be installing jacks on the TP cable and F connectors on the coax cable. Now the first step is to remove the cable from the rough-in ring or box and inspect the cable for cuts and damage that might have been caused by the sheetrocker. Then you want to cut the cable between 12 and 18 inches, relabeling if necessary. I'm going to go ahead and cut these, relabeling them first. The tools you'll need to install the cable on the modular jack are the same as you used for the 110 connectors. First, strip back about 2 inches of insulation using the cable stripping tool. The TP jack uses a similar type of 110 style insulation displacement contact. The jack has color coding to indicate the correct wire color for each contact. Be sure to use the A color coding on the jack. Start with a blue pair, untwisting it down to the jacket. While keeping the jacket as close as possible to the connector, apply the blue pair to the blue and blue-white color-coded contacts. Next, install the orange pair to the orange color-coded contacts, keeping the pair untwisting to a minimum. Next, install the green pair, pushing them down on the insulation displacement contacts and keeping its untwisting to a minimum. Then finish with the brown pair. Now, when you punch these down in the field, it really helps to have something like this plastic surface to punch down on. Never try to punch a connector like this down on the sheetrock or on your hand. It's very easy to slip and cause some permanent damage, either to yourself or to the customer's home. If you need to install modular plugs in the distribution panel, you'll also need a plug crimping tool. As before, strip off about 1.5 to 2 inches of insulation. Separate the 4 pairs into the order green, blue, brown from your left to right, with the orange pair on top. This will make untwisting easier and keep the wires in the correct order. Carefully untwist each pair down to the jacket. Smooth out the twisting in each wire by pulling the pair through your thumb and index finger. Reorient the wires of the orange pair by placing the orange-white wire between the green and blue pair and the orange wire between the blue and brown pair. Hold the wires flat between your fingers in the order from left to right: green-white, green, orange-white, blue, blue-white, orange, brown-white, and brown. Keeping the wires in the same order, carefully bring them together, rubbing out any twists. Cut off any ends if necessary. Hold a leaven and plug with the locking tab down and carefully slide the wires into the plug. There are channels in the plug to guide each wire. Push the cable all the way in until the insulation is seated in the rear channel under the insulation clamp. Insert the plug into the crimping tool until it snaps in place, and crimp the tool through its complete ratchet cycle. This will cut off the wires flush with the connector. Check the plug to make sure the contacts are properly seated and the insulation is under the plastic clamp in the back.
Next, I'm going to punch down the data cables on the termination blocks. We'll need 3 of them, and these have been labeled at the shop to help identify which cable goes where. All I need to do is cut the cable to the right length, apply the new label, and punch it down to the connector.
The task here is exactly the same as for voice lines. Measure, cut the correct length, relabel, and punch down. We'll check on his progress shortly. Now, attaching F connectors to coaxial cable is easy. We're going to use these Channel Vision push and snap style connectors. Now, when you're using quad RG6 cable, make sure you're using a quad RG6 connector. The connectors for regular RG6 look almost the same. If you plan to use the snap and seal type of connector, you'll need a cable stripper and the compression tool designed for the specific connector you're using. If you're using regular crimp style F connectors, you'll need a ratcheting crimping tool. We'll demonstrate installing this type of connector first. The first step is to strip the coax for the connector. Stripping tools for F connectors will make 2 cuts in the end of the cable. The first down to the center conductor, and the next through the outer jacket down to the foil. Use a stripping tool that has a blade depth adjustment to allow you to fine-tune the depth of each cut. Practice on scrap cable until it makes a perfect cut. The tool should strip so that there's 3/8 of an inch of center conductor and 1/4 inch of inner foil showing. The connector body is designed to take the dielectric and surrounding foil of the coax through the center hole. The center conductor becomes the center contact. We'll start with a hex crimp connector. The first step is to force the connector into the coax so the inner barrel is forced under the braid shield and over the inner foil, until the center dielectric insulation is flush with the front of the center barrel. Then, using a ratcheting crimping tool, place the connector in the correct die position for the type and size of the connector you're using. Complete the crimp by closing the handles until the mechanical cycle has been completed and the ratchet releases. The barrel should be firmly crimped against the outer jacket. Next, I'll demonstrate installing the snap and seal connector here at a master bedroom outlet. Prepare the cable the same way. I like to remove the outer braid and foil and fold back the inner braid over the jacket. Apply the connector the same way, making sure the dielectric is flush with the inside edge. I then apply a connector to the internal cable. With the ratchet fully open, insert the front of the connector into the tool so that the center conductor passes into the alignment hole. Then snap the cable into the locking jaws, then crimp the tool through its complete ratchet cycle. It's a snap. Now, when you're done with the crimping, you shouldn't be able to pull off the F connector with anything less than 40 pounds of pull tension. And make sure you check off that you've connectorized each cable as it's done. In bedroom 2, Jason discovers a common problem. One of the coax cables was damaged, probably when the sheetrock was installed. Fortunately, there's enough slack so the damage can simply be removed. Like Jason, you can also use the pull cord to strip back enough TP insulation. This puts any possible conductor nicks from the initial strip back past where the conductors will be punched down. Jason also uses a handy tool to push the coax connector on the cable, saving some finger wear and tear. And finally puts on the finished labels. Meanwhile, I install a basic wall phone plate in the garage that uses screw terminals. and get the single data outlet for the wireless access point in the closet. Then continue with the outlets in the kitchen, making sure I check off what's been installed as I go.
Once the TP voice and data cables are done, I'm going to get started on the coax and the RF distribution panel. Now once again, to get the cables cut to the right length, I'm going to put most of the modules into the panel according to the panel layout diagram. I'll start with the splitters, which accommodate 16 of our external cables.
In a process similar to the voice cables, Rich measures where each cable will terminate, cuts it to the correct length, relabels, and applies the connector. Meanwhile, Steve and I tackle the 6 outlets in the entertainment center. Rich, you about done?
Yep, just getting the last F connectors on.
Great. Well, now that we've got the connectors on, the cables punched down, it's time to test our TP and coaxial cables.
There are 2 classes of tests for category-rated TP cable: verification testing and certification testing.
Now, verification testing is required, and it tests for the most common problems in the cable and connectors: pair opens, pair shorts, and proper connector wiring. Make sure the pairs go to the right set of contacts on each end.
And it helps us check to make sure that the cables are labeled correctly.
Right. Now, all of these potential problems can be caught with simple TP and coax test equipment. And so now that we've got these done, let's start here on the TP, and we'll work our way up.
Okay.
There's a variety of very good, inexpensive test equipment you can use to perform verification testing, such as the Ideal LinkMaster, Mini Tracker, and VDV Multimedia Cable Tester. The Fluke Micro NetBlink, Micro Probe, and Micro Mapper, as well as equipment with more advanced testing features, such as the Fluke Microscanner Pro, with wire map and distance to fault capability, and the Ideal LinkMaster Pro, with similar wire map and fault isolation capability.
Let's cover Cat5 cable testing first.
Okay, now to test cable requires something attached at each end of the cable. This Fluke Microscanner Pro is a good example. It consists of a push-button tester and a remote, both attached directly to the cable under test.
Now, it really doesn't matter which connects at which end, but typically you connect the remote at the outlet end and then use the cable tester here at the distribution center.
Right. Now, we're going to go right down our cable schedule, testing each TP cable as we go. So why don't I take this end and you take the remotes?
Okay, that's fine. Then I'll start with cable 1A, outlet 1, master bedroom.
Good. Two-way radio on?
Yep, 10-4.
Okay, good. Now the job is a heck of a lot easier with a pair of these family band radios. Now the disadvantage of having all of the voice lines connected in parallel like they are on these voice modules, if there's a short on any line, then it's a little tricky to find because it shows up on a short on every line. Now I'm going to use this little Ideal LinkMaster to do a simple open and short test on each one of the modules to make sure we're not shorted before we start our tests. And good, I've got an open condition here on all the lines. An open condition on voice module 2, and cross your fingers. Good, we've got an open on each module, so we're ready to start our test. Okay, Rich, go ahead and plug it into 1A.
All right, Grayson, I'm on 1A.
Okay, I'm just going to go ahead and plug it into the voice module, and good, I've got a good, got a pass condition, good wire map. The display indicates the actual wire map of the cable and connectors you're testing. That is, which pin on one end is connected to what pin on the other end. The top row indicates the wires detected at the tester, and the bottom row is what was detected at the remote. This shows a good one-to-one connection. A typical fault might show up something like this reverse pair at the remote, or an open pair somewhere in the cable. It can also indicate the distance to an open or short to help find the location of the fault. Check off or initial the cable on the cable schedule as it's tested.
There you go, I'm on 1B.
And that's module 1. And good. Okay, I've got a pass condition there. Now let's go to 2A.
I'm on my way.
Okay, 31 looks good. I think looks like the next one's 32.
Okay, test 32.
Well, we've got a fault condition. Now, it looks like we've got an open on the 4-5 pair, and the tester indicates that it's on the cable end. Rich, looks like I've got a fault on the blue-white pair, and it indicates it's on your end. Can you double check it for me?
Sure enough, I can see that the white wire on the blue pair is not punched down, and I'm going to go ahead and repair it. Okay, go ahead and test 32 again.
That did it. We got a pass. Okay, let's keep going. Now, it's easy to test coaxial cable the same way using low-cost testers specifically designed for coaxial cable, like this little mini tracker. Now, while all of our testers are capable of testing coaxial cable, we're going to demonstrate the mini tracker's big brother, the LinkMaster Pro. Like the mini tracker, this thing comes with a bunch of color-coded remotes, so you can identify and test several coaxial cables at the same time. The remote screws in at the outlet. You can use a barrel connector to do this. If you do several at a time, remember to know which color is on which cable on your cable schedule. The tester plugs in back at the distribution panel. Okay, Rich, I got yellow on 4C and red on 4D.
Roger that. I've got red on 4D. I'm going to go check 4C now.
Okay. Once on, the tester automatically performs the test, detecting the color code of the attached remote. Remember, this can be used to verify correct cable labeling. Okay, Rich, I got yellow on 6B.
Roger that. Yellow on 6B.
We continue testing, working our way down the cable schedule. Okay, Rich, I got yellow on 7C, red on 7D.
I got it. Grayson, I'm reading an open on 10A. You sure you've got red on 10A?
Yep, 10A red.
Okay, let me check into this a little bit.
What do you think the problem is?
Well, we've either got a broken cable or a mislabeled cable because I'm reading wide open on 10A.
Okay, well, let's track it down. Well, the easiest way to find a mislabeled or broken cable is with a tone generator and tone detector. You know, one of the handiest pairs of test tools you can have. Now, we're going to be using this Harris TS90 tone generator to put a distinctive tone on the cable that we're trying to find. And we'll use this ideal signal probe to track down the cable at this end.
Well, Grayson, why don't you go ahead and put the tone generator on our suspect cable.
Sure.
And I'll see if I can tone it out from here.
All right. I simply attach the generator directly to the cable. Okay, it's showing 95 feet, so I don't think it's busted. I don't think the cable's broken. The detector's pickup coil will detect the tone within a foot or so of the cable. When cables run close together for any distance, the tone can be coupled to other cables, so it takes a little practice to sort out the strongest tone. But the Harris generator's got a nice feature. If you short the cable connected to the tester, the tone changes, so you get a good confirmation you've got the right cable.
Well, Grayson, it looks like I found it. It's on 9C. I probably mislabeled the cable when I wired up the head end.
Okay, Rich, I got red on 49, kitchen.
Check, got that one. Well, that went easy. Only a few mistakes, and luckily not a single problem in our cable installation. Only one mislabeled cable.
You're lucky this time. But it's easy with 2 people and radios. Now, we could also perform certification testing on our data cables using a high-quality certification tester. This Fluke DSP-2000 is a good example. The remote unit plugs in at the outlet, and the tester plugs in at the distribution panel. It performs all the compliance testing outlined in TSB 67, the TIA document that defines the necessary tests and pass criteria for each category rating. But it can also perform a wide range of diagnostic tests, such as near and far-end crosstalk graphs, locations to a fault, and graphic TDR results.
You, the installer, are certifying to the customer that the cable, components, and installation meet those specifications. And luckily, you have the documentation from the tester to prove it.
Right. Now that we got the testing done, let's go put the wall plates on.
Okay.
I'll start in the master bedroom, and you start somewhere else. Now that our cables are tested, it's time to put the wall plates on. At this location in the master bedroom where we've got 2 TP and 2 coax cables, I'm going to start by mounting the jacks in this 4-port wall plate. I'm going to start with the coax connectors on the bottom, and they just snap in most of the time fairly easily, with the TP connectors on the top, starting with voice, data. Now, try to keep the connector color coding and placement consistent. Your job is to minimize customer confusion. This means making it very easy for the customer to identify the function of each jack. Now, you can also choose to label your jacks like this. Now, this lets you keep everything the same color, but these labels can be hard to read, especially for old guys like me. If you do choose to do it this way, again, make sure you keep the placement of each type of jack consistent. TP on the top, coax on the bottom, data on the right, phone on the left, and so forth. We chose to use a color coding scheme with blue jacks for voice on the right, red jacks for data on the left. We chose to use this gold F connector to identify the RF out external cable runs, and this nickel-plated connector for the RF input internal cable runs. And be careful when you're trying to put the cable back in. It's very hard sometimes to get all this cable inside a wall and get the plate mounted on the wall without popping the connector out or damaging the connector. If you're using barrel connectors without built-in terminators, be sure and install screw-on terminators on each connector.
At this location, co-located with the electrical outlet, we'll use this snap-in frame to hold the jacks. Now these also come in 1, 3, 4, and 6 ports. This will allow me to use a 2-gang wall plate after the frame has been mounted.
At the wireless access point location in the closet, I trim out the single data jack. We provided a separated double gang box for the electrician to co-locate the outlet, but I guess he got confused. He put the extra outlet 2 feet to the right. We continue working our way down the cable schedule. In the entertainment center, several of the outlets require 6 jacks, a tight fit for a single gang box. The blank side of these outlets are available for interconnect cables that may be required between shelves. While Rich and I are finishing the wall plates, the ASL crew is completing the installation of the security devices. Here, Steve installs a typical window magnetic sensor. He first marks the location of his cable on both the frame and the sliding pane. Retrieves the cable, strips and preps 2 conductors, and attaches the conductors to the switch contact. He then centers and secures the contact to the frame using the contact adhesive backing. He then preps the track of the pane and attaches the magnet with its adhesive backing, plus a dab of sealant for good measure. At each door, ASL installs a recessed contact in the frame. It's installed by directly crimping the pigtail wires on the sensor to the conductors of the cable. The crimp connectors and cable are then pushed into the opening, and sealant is used to secure the contact in the opening. Steve marks the location of the contact on the door, drills the hole for the magnet, and secures the magnet in place with sealant. Meanwhile, Jason installs the first of 2 motion sensors. They use 2 conductors for power and 2 for a normally closed contact. We have 2 Omni keypads, this one in the master bedroom and the other at the utility room entry door. After measuring the correct height, Steve uses the back to mark the cutout and mounting holes. Cuts the cable opening and retrieves the cable, then secures the back to the drywall. He preps the cable and attaches the provided connector using the pigtail conductors. So you're getting ready to put the stuff in the security panel.
Yeah.
Well, let me give you a hand.
Okay.
Now, we've got the A-bus in here, the HAI panel, and that's about it other than the security equipment.
That's it.
Okay, so these are our audio cables.
These are for
these
the
are
A-bus.
security stuff, and these are all your security sensors.
Right.
Okay, well, let's get started. You want to start from the top down?
Yeah, let's start from the top down.
All right. Why don't you grab that. So the panel just snaps in. Okay, here, let's stick the A-bus guy in. So you're just going to come down with your cables and wrap around.
Yeah, we'll tie them off to the side so it keeps everything nice and neat.
Okay. Let's get the power strip. You want that a little high, out of the way of. It's okay to put these cables behind there?
Yeah, there's a little bit of a gap back there, so we can put them behind there.
Yeah,
Keeps
you want to
everything
go a
out
little
of the way.
higher than that. See the mark?
Yep, you're right. Missed that one.
Yeah. Okay, so the A-bus power supply then, so we've got the X10 module that's going to go in there, and you'll have the power supply for the board.
Yeah, the transformer will
battery.
sit in the bottom.
Okay, and then the A-bus power supply is going to go in there and power that thing, right?
Yep.
Okay. Well, if there's anything I can do, since we put the this stuff in, I wrote on there where the each wire goes to the panel.
Okay.
So I'll let you get started on it. I'm gonna go start on the cameras outside. We'll catch up with you later.
All right.
Okay. Eric starts the process of sorting out the security sensor cables and getting them organized into zones for attachment to the security processor board. Next, Rich and I are going to mount the cameras inside and outside. I'm going to install this one on the front porch. Now we're going to use these small bullet style color cameras, and I've gone ahead and pre-mounted these on the plates in the office to save time during installation. The 12-volt DC power connector conductors are crimped to 4 conductors of the Cat5 cable. When distributing power over Cat5 cable, use at least 2 of the conductors for each polarity to minimize the voltage drop in the cable due to the resistance of the wire. We standardized on combining the orange pair conductors for positive and the green pair for negative. I'm using a 2-piece crimp connector. First, slip the crimp ring over the cable. Then remove an inch of insulation. The video cable uses BNC connectors. And since I didn't have a coax stripper set for BNC dimensions on the site, I had to do it the old-fashioned way. Familiar to many of you, I'm sure. Peel back the outer braid, remove the inner foil, peel back the inner braid, and trim them to about 1/2 inch. How much insulation you remove and the center conductor length depends on the brand of connector you use. The connector pushes under the braid, and the braid is folded over and under the crimp ring. The ring is then crimped tight to the jacket and braid. There you go. The connectors push back into the outlet, and the camera is attached normally. Yes, as always, the stucco crew has some patching to do. Finally, I do a rough position adjustment and set. We'll do a final adjustment during configuration. Meanwhile, Rich uses the same procedure to install the in-wall camera in bedroom 1. The lens is recessed in the wall and is covered by a plexiglass cover. Steve finishes up the camera in the great room, the same type we used outside. Now, we're going to be using a Core Access Omni 6 home control and user interface system. Now, installation is simple. It consists of simply attaching power, our Ethernet network connection, and a serial interface back to our Omni LT home automation panel. Once the cables are attached, the panel screws right to the rough-in box, and the cover just snaps in place. Very nice.
Next, we'll install the HAI Omni thermostats, one for each of 2 heating and cooling zones in this house. This is a single-stage thermostat for heating and cooling, which is what we need in this application. They're wired directly back to the Omni controller, and they connect to the HVAC equipment just like a normal thermostat.
Since we forgot to get Rich the right tools for this shot, he had to attach the HVAC wires with his pocket knife. He then attaches the supplied serial interface connector to the Cat5 cable from the panel using crimp connectors.
It looks perfect, doesn't it? Okay.
What the heck is this cable, and who botched up the raw fan opening? The thermostat for the master suite zone is mounted in a poor location for monitoring temperature, so we installed a separate temperature sensor in the center of the space. We mounted a shelf for the wireless access point and attached the power module and data cable. Next, we're going to be installing the in-wall and in-ceiling speakers. Now, we're using ChannelVision's A-Bus audio distribution system. The volume controls receive baseband audio and power over Cat5 cable from the distribution panel and output amplified audio to the locally attached speakers.
There is a row of LEDs which indicates the volume level, and a built-in infrared sensor which sends infrared signals back to the input module in the entertainment center.
Right, convenient remote control from anywhere there's a volume control. Well, it looks like Steve has already started installing the in-ceiling speakers here in the dining room, right, Steve?
That's right, Grayson. I'm going to be using Channel Vision's round retrofit, very easy to install speakers.
Okay, one on each corner here, looks
Yes.
good.
Yep.
Well, I'll give you a hand putting it in.
Okay.
And I'll go ahead and get the volume control installed.
Okay, thank you, Rich. Well, you've already got the thing marked.
Yep.
Very good.
Ready to cut.
All right. Well, Steve, I know we staple these speaker cables up here real well, but looks like somebody decided they were going to do us a favor.
Yeah, it's a common mistake. Somebody just stubbed that out for us in the wrong spot. We'll just have to pull it back through and just patch over it.
That's the cable. And it looks like they did a little odder job on the other side. Why they picked that place, we have no clue.
Again, it's an easy fix.
Yeah, but it's typical for residential installation. You always run into these screw-ups when you come back on the job.
It happens.
Okay. What do you need first?
I'm going to put on my glasses and I'm going to go ahead and cut some drywall. So if you
All right.
hand me my drywall saw.
Okay. Like most of the ceiling installations, we ran a 2-conductor 16-gauge cable to each speaker from the volume control. The black conductor to the negative terminal and the red to the positive terminal. Recessed screws engage the locking tabs and secure the speaker to the sheetrock. And the grill just snaps into place. Now, in the master bedroom, we pre-wired for 2 in-wall speaker locations on the east wall or west wall, depending on where the customer put their bed.
Well, the builders told us that the bed is going to be over on the east wall, so we're going to work over here on the west wall.
Okay. Now, why don't we get our location marked from our notes we did at pre-wire. On the left here, where the middle of the stud bay is 22 inches in.
All right. Right there.
Okay. We're going to be using these rectangular Channel Vision in-wall speakers, and they come with a template to help us cut the hole to the right size.
Okay, I talked to the builder about this. He was okay with 60 inches above the finished floor to the
Okay.
bottom of the speaker.
All right, we've got that marked.
If this was the stud, I want to come in about a 1/2 inch so that the ears have sheetrock to grip.
Yeah.
Right? So I'm going to slide over about a 1/2 inch.
Okay.
And I want the bottom of the frame to be at my 60-inch above finished floor mark.
Okay.
Okay, perfect.
All right. And it's somehow right on top of looks like we're clear.
Okay, I'm going to cut this hole.
All right, go ahead. Good.
There's our wire.
Well, we lucked out this time.
Okay.
During pre-wire, we daisy-chained a 14-4 cable from the left side to the right. So we have to crimp the red-green pair of both cables together here for the right speaker.
Okay, white to positive for left channel. And black to negative for left channel. Good connection.
All right.
Okay.
Get the grill back in.
Beautiful.
Okay. While Rich mounts the other speaker, I tackle the volume control. Since we pre-wired to both sides, I select the correct 14-4 cable. I prep the Cat5 cable from the panel and punch it down to the 110 connector. I then prep the 14-4 speaker cable. Red-green for the right speaker, white-black for the left. I want to store the other pre-wired speaker cable for easy retrieval in case the homeowner decides to rearrange furniture. Earlier in the dining room, Rich connected separate 14-2 cables for each speaker, making sure to get each speaker wired to the correct side. While Rich continues with the volume controls, I mount an A-Bus source module in the entertainment center. This interfaces the baseband analog inputs to Cat5 cable. I connect it to one of the Cat5 jacks that's wired to the A-Bus termination module in the 28-inch enclosure. You get it okay? Mm-hmm. Our last stop is up here on the roof. We need to mount the FM, the broadcast off-air antennas, and the satellite dish.
The off-air antenna is for DTV only. So we're going to use a good UHF only Yagi Uda antenna.
Yagi it is. Okay, let's get started. Rich, why don't you take the FM antenna, I'll take the broadcast off air. When we get done with those, we'll start on the satellite dish.
Okay, sounds good.
All right. Earlier, I made sure we could get the needed signal strength on this part of the roof while pointed directly at the broadcast site on top of an 8,000-foot mountain about 25 miles away, and to make sure reflections weren't too bad from the adjacent mountain. We started by mounting two short masts sufficiently separated to prevent interaction, at least 3 feet. Then mounted the antennas. We're using an omnidirectional FM antenna since FM stations are located all over the place.
That looks good.
Yeah, it's not too bad. Next, we retrieve the 6 coax cables and ground wire we pre-wired. Put an extension on it.
Okay.
Will it reach the base of Rich prepares a short RG6 cable using weatherproof F connectors that'll go from the FM antenna to the grounding block at the base of the UHF antenna,
OSHA approved
and connects it to
boot
the
tank.
ballon, covering the connectors with weatherproofing boots. Okay. He then connects a length of 10-gauge ground wire from the mast to one of the 2 grounding blocks we secure to the base of the UHF antenna, and connects the coax to the block as well. Don't have a little setup. I connect the ground conductor from the house to the other grounding block.
No luck.
Rich attaches and secures another short coax cable from the UHF antenna to the grounding block. With a signal level meter attached to the block, we then align the antenna. Antenna's right on the top of that mountain over there.
The big mountain?
Yeah, so
Okay.
we've got a line of sight path right to it.
All right.
So you can almost aim this thing right by sight. Once aligned, we attach the coax cables from the distribution center to the grounding blocks. You know, this thing looks a little flimsy for the roof here, I think with a wind load.
Worried about that.
Yeah. I think we'll come back and put a heavier duty, I can put a
do
little,
a platform base?
yeah, either that or I can put a little triangle mount in there.
Yeah. Okay.
That'll do it. This, even though this, I thought this was short enough it would do it, but it's a little too long.
Okay.
Let's go get the
come back and
satellite
do
dish.
All right.
Rich gets the job of preparing the cables, while I mount the mast, aligned with the slope of the roof. The mast contains a small bubble level to make it easy to get the mast perfectly vertical. I tighten the mast in place. I then set the approximate elevation on the dish for our latitude. Then mount the dish on the mast and tighten it down, but loose enough so we can still aim it. Then we do a preliminary azimuth alignment using a signal level meter attached to the primary LNB.
That's it. You're
The meter supplies the necessary power to the LNB.
Okay.
Relock it. We then attach our 4 LNB cables from the multi-switch. Left and right-hand channels from each LNB. We'll do a final alignment after the homeowner equipment is installed.
You good with that?
Yeah.
Okay, well,
right.
I think that takes care of everything, except let's get the equipment installed in the panels downstairs and get the networks configured.
Okay, well, let's get all this stuff off the roof. I gotta go take a leak.
Hi, Steve. How you doing?
Good, how are you?
Excellent.
What happened to Eric?
He had to go.
Well, I hope you're gonna finish up the panel today with us.
We sure will.
Okay, give me a little overview of what you're doing here.
Well, we're just grouping the wires together by zones.
Okay.
And then we're going to land them on the panel itself. Get that going.
Finish up the sensors first, then I hope you're gonna do our A-bus for us.
That's right.
Good, excellent. Hey, I meant to remind you that I need Cat5 cable from the HAI board for our line seizure to the RJ31 that's on our voice module over here.
Sure.
Because that's where our lines are coming in.
All right.
Okay, so Rich and I are going to try to finish these panels out today as
Okay.
well.
All right,
So
I'll just
we'll be
continue.
keeping you company here.
Great. I'll just finish this up for you.
All right, Rich, let's get
RF
we'll
City.
start on the RF panel. Let's do it.
Okay.
Okay.
S3 and S2.
S3 and S2. That's about right. We already mounted the main internal and external splitters, so we only need to mount the remaining intermediate internal and external splitters. We then mount the main external distribution amplifier.
Okay, that gives.
You can follow along with the layout diagrams in the back of the workbook.
That's about it right there.
Next comes the internal signal amplifier. Rich then starts from the bottom and mounts the satellite multi-switch. Then the 4-channel camera modulator. With the modules mounted, Rich starts on connecting the external cable runs to the two 8-port external signal splitters. He then works on the internal cables to the 4- and 6-port internal signal combiners. We then connect the jumper cables we pre-made at the shop to interconnect the components. We'll connect the remaining cables from the satellite dish to the multi-switch inputs and connect the off-air and FM antenna cables to the F connector terminating block. When the homeowner equipment is installed, we'll jumper the necessary outlet cables to the multi-switch outputs, off-air antenna, FM antenna, and so on. While Rich continues with the coax cables, I mount the router in the voice and data panel. Next, I install the two 8-port switches mounted on a common bracket over two of the data cable termination modules. This is a bit tricky. Then I start at the bottom and mount the power distribution module. Next in is a bracket to hold the camera web server. The server slips in and is clamped in place. With most of the equipment in, I install the main 15-volt power supply and connect it to the power distribution module, and then install the router power supply. We pre-made the power cables for the two switches in the office and connect them up to the distribution module. We also pre-made any other cables we could, including this power cable for the camera server. I then prep the Cat5 part of the 4 camera cables to combine the power conductors and apply the connectors, and plug them into the jack supplying regulated 12-volt DC. Rich and I begin installing the voice and data jumpers, first between the voice modules. These are commercially made Cat5 jumpers. Referring to our design drawings, we installed jumpers from the 4-port switch in the router to the two 8-port switches. Then from the camera server to the router switch. And from the wireless access point cable to the router. We then complete the remaining jumpers from the data outlets to the 8-port switches. last one, right? After lunch, we need to connect the camera coax cables to the 4 video inputs on the camera server. We made up some BNC T adapters with BNC to RCA adapters on one side, so we can daisy chain the video signal through RCA cables from here over to the RF panel to connect the camera video to the 4-channel modulator. Meanwhile, back at the ranch, while Rich and I have been working away on the data and RF panels, Steve's been working away on DC3. He's finishing sorting out the security zones and connecting zone sensors, keypads, and alarms to the Omni screw terminals. Next, he punches down the Cat5 cables from the volume controls to the A-bus audio distribution panel. The audio source cable will be punched down on the connector on the far left. Steve then connects an X10 Powerline interface module to the panel and plugs it in the power strip. Steve feeds me a Cat5 cable used to feed voice line 1 to the Omni panel for alarm line seizure. See, if you need to test this thing, this little switch, this will throw it into normal, bypassing the security panel.
Right.
If I throw that up, then it's in the circuit.
Gotcha.
He preps the cable and attaches it to the Omni panel.
No friction? Oh, this is great. Piece of pie.
These are the RCA cables we mentioned earlier that feed the camera video from the camera server over to the modulator.
Once the equipment is installed and interconnected, we need to perform initial tests and configuration, starting with the voice network.
Now, if telephone service is available, you can make a final check of the voice network with a telephone butt set like this Harris TS29. Now, this will check for active dial tone and allow you to either monitor the line or put it in talk mode and dial out to double check the network's working. Now, this normally comes with a pair of telephone clip leads, but we attached a modular connector here to make our job a lot easier. Back to you, Rich.
You should pre-configure as much of the network equipment, such as a router, wireless access point, and servers, as you can at the office. You should also make a network configuration worksheet. A sample is in your workbook. It lists all the network devices with their configuration information, such as IP addresses, ports, and so on. This is extremely valuable later if you need to troubleshoot the system. Our first step was to power up the panel and check for good status lights on the equipment. Then check for link lights between the switches, the router, the wireless access point, and the server. Now once the panel looks good, and it does, Grayson and I will check the configuration and test all the data outlets. Okay, everything looks good at the panel.
Okay, well, I'm using our network configuration worksheet to double check the configuration of all of our components, make sure they're still what we set them at.
Well, while you're doing that, why don't I go around and test the rest of the data outlets?
Okay, good. Now, Rich is going to use a Fluke link runner to double check that we've got a good 100 megabit per second link at every outlet.
If I find any trouble, I'll let you know.
Okay, good. Now, even though we don't have a broadband internet connection yet, we can certainly check everything on the LAN side of the network. Now, I've gone ahead and pre-configured static IP addresses for our wireless access point, camera server, core access panel, and so forth. And I've pre-set up some of the security settings as well as virtual server settings for the camera server. Now, when we return for homeowner for familiarization, we'll complete all the security settings. Rich pre-configured the link runner with the IP address of the router. He plugs it into each outlet and presses test. It'll execute a DHCP protocol, get an IP address from the router, and ping the router. It would also ping the DNS server if we were connected to the internet and display the results. An excellent tool for troubleshooting the network in the field. Now, next we're going to configure the wireless access point. I've gone ahead and set up the SSID with SSID broadcast to set the channel number, and we've temporarily turned on WEP encryption. Again, we'll reset this with a homeowner later. Now, once I've got this running, I'm going to unplug and connect via the wireless access point.
Well, how does it look?
Good. Well, good signal in here, just in case the homeowner wants to float his laptop in the tub.
Well, wouldn't you?
Gets in the way of my ducks and battleships.
Ah, of course.
So how's your testing going?
Well, it all looks good. I'm ready to go check the other end of the house.
Good, that's where I'm headed.
Okay.
It's also a good idea to check the signal strength outside on patios and porches. There's a pool going in here in the backyard, so the owner is likely to want to use a laptop in this area. Next, I'll configure the camera server. Bring that up. Now, the server shows all 4 cameras at once. They're not aimed yet, but we'll do that later. Now, I can configure how often the cameras refresh and how they're accessed from the internet. Another thing to go over with the homeowner.
Well, everything checks out okay.
Great. Last thing I think is the core access panel. Why don't we make sure that's operating right and get it configured?
Okay, I'll connect the power.
All right. Okay, good. It's booting up.
Oh, great.
Now, let me check the panel has its own built-in diagnostics to show its IP address and whether it has a good connection to the internet. Okay, now let's check its configuration. We can set up all the initial panel settings, including webcam sites and our camera web server address, so we can view our cameras on this screen. We also need to configure the interface with the Omni security panel, since the core access panel has a graphical user interface option for the Omni built in to handle thermostat settings, lighting controls, security status, and settings. And we'll cover that with the homeowner.
Okay. As Grayson mentioned, we'll need to discuss security issues with the homeowner. WAN firewall settings, virtual server settings, wireless security, and recommendations for individual computer security.
Right. Now, each computer needs to be running its own security software, virus protection, and needs to be backed up regularly.
Well, let's tackle the RF distribution system.
Okay, guess it's time to do that.
Okay.
Now, the first step in setting up the RF distribution system is to set the main amplifier gain and tilt. Now, to do that, I'm going to inject a 0 dBmV reference signal into the cable input port of our system here. Rich, if I could get you to do that for us.
Sure.
Get that started. Now, I'm going to set the signal to a high channel and then a low channel, and then measure the output level at the farthest and closest location in the house. Now, since we don't have cable service available yet, I'm going to use my own homemade cable service. Now, this is a baseband video generator attached to a frequency agile modulator, and the output routed through a variable attenuator so I can easily set the output to whatever I need. Now, Rich, I've already got this thing set to channel 118, our high channel, 0 dBmV output.
Right.
So I'm going to take the signal meter and go to the farthest location, which is the master bath.
Right.
I'll tell you what I get, and then if you help me adjust it, we'll go to the low channel.
Okay, radio's on?
Radio's on.
All right, I'm ready.
The first step is to measure the signal level at the highest channel, channel 118. We want the level to be between 0 and plus 10 dBmV. Okay, Rich, I've got plus 12.4, so let's bring it down a little bit. Go ahead. That's good, that's good. Okay, you're a little low. Bring it back up a Schmidt. Okay, good, good. You got it right there. I got plus 5 dBmV. All right, we're going to go to channel 14. Next, we go to a low channel. Channel 14 is the lowest we can set on the modulator. With the same input level. Okay, Rich, I got about 8.49. We then adjust the tilt setting on the amplifier for about the same level at the signal level meter. That sets the initial gain and tilt for the system. We'll fix it right there. We also check the level at the closest location to the amplifier to make sure that location is not overloaded. In our case, we're reading about plus 10.5 dB at channel 14, so we're in good shape. Rich and I double check the level at each outlet and record it on our test sheet. It's also a good idea to use a portable TV you know is working correctly to visually test the signal. This will also make sure there is no hum or interfering signals on the system. Next, we need to check the internal signal distribution. We'll do this by injecting a modulated signal on one of the internal cables here at the entertainment center. I set the generator to channel 86, a typical channel to set the modulator of a satellite receiver. And adjust the signal level for plus 25 dBmV, and plug it into the internal cable. Rich checks the level at several locations and records the results. It should be between 0 and plus 10 dBmV. Press the select button. Next, Rich and I set the camera modulator. Each of the 4 channels can be set independently.
Okay.
We program the cameras on channels 88, 90, 92, and 94. We've notched these analog channels out of the incoming cable service with a notch filter. The output level of the modulator is fixed, so we double check the level. We need it to be close to plus 25 dBmV to get the levels we need in our outputs.
Yeah, got 27.
That's
good.
within range.
That's within the range. And at 92.
A little high, but still in there.
It's a little high, yeah.
So we add an attenuator to its output, and that sets the level where we need it.
Go ahead and let's measure that again. Okay, so my high channel level is a little better now. Yeah, it's within my range.
Great.
Yeah. Okay, we got it.
Well, now that we have the RF system up and configured and the camera modulator working,
Wow.
we can go test and aim the cameras.
Good. Let's use the TV in the kitchen.
Okay.
Okay, and if you can, that's good. Now, if you can rotate it, let's see, to your left, counterclockwise or clockwise? Yeah, that way. Okay, whoa, right there. Excellent, that's got it. Wave. Okay, works good. A quick flip through the camera channels shows which ones are working okay and which ones still need some alignment. Earlier, ASL programmed the security panel, so we just need to check that all the sensors are working properly. While I walk around the house, Rich checks the sensor status on each zone, including all the door and window sensors.
Okay.
I also check to make sure the telephone remote access function is working. This lets the homeowner operate the panel functions from any phone inside or outside the home.
Security mode is off. Zone cancel. Please choose. Phone. Please choose. 8. Play. Address. 9. Record. Address. Cancel.
We also check the thermostat operation, not only that they control the HVAC zones properly, but to make sure they can also be operated from the Omni security system. Okay, it works. We then make a final check of the core access system to make sure it has an internet access through our temporary internet connection, and that the serial interface to the Omni panel is working. The display of remote webcams is a sure sign it's got a good connection to the internet. Finally, we test the audio distribution system. I'm going to use iTunes on the laptop as a handy audio source. I plug it into the A-Bus baseband input adapter. Rich then checks volume control operation in each room and makes sure there are no rattles or vibration from any of the speakers. You should always keep a copy of the field documentation, wiring schedule, test results, network configuration worksheet, and so on, on the site as well as the office, preferably in the enclosure. We're going to keep them in a plastic bag taped to the inside of the enclosure door. Be sure and include your business card as well. Also, make sure you have copies of any configuration files in your laptop and store them in the customer database when you get back to the office. Now, we'll have to return after the homeowner moves in to familiarize them with the operation of the system. There's still a lot to configure based on customer preferences.
Particularly the home automation and security systems and the security settings of the data network.
And we'll assist with setting up the access provider and the ISP.
And hook up the AV gear to the audio distribution system.
Right. Well, that completes our course. As always, thanks for watching. We hope this has been an enjoyable and educational program. Got something cold to drink. I think you're buying.
Well, sure. Hey, I thought you said there were going to be babes in this video.
That gets them every time.